All right, guys. Now we're going to go on to our next session. So this one is going to be hosted by Mikayla Sprague. So Mikayla is a mechanical engineer. She's got over 6 years experience in the automotive industry. She's proud to say one of my colleagues, and I'm thrilled with the work she's done for me and my clients. And I'm happy that she's going to talk to you today about knowledge modeling. So we're going to get a little bit more advanced from the initial conversation we had with Ashley. Please, if you don't mind, ask questions, let me know, but I'm going to run a mic over to you. I apologize. We want to get this all on video so you can watch yourself over and over again afterwards. Okay, I'm a biz dev. I got to shut up. I'll turn it over to Mikayla. Go for it, Mikayla.
Thanks, Jim. Welcome, everyone, to knowledge modeling. This is still a foundational course, so very basic knowledge modeling, but we'll get into it a little bit. So the learning points of knowledge modeling, we're going to talk about value tables and methods. And then we'll also get into the fidelity of evaluation, attestation versus model-based evaluation. So knowledge modeling increases the fidelity of evaluation and reduces human error. It produces robust models that enable data to be captured in a normalized format, results in real-time evaluation of knowledge, and increases throughput of evaluation. So as an example, if you're a designer with a design review process and you have a CAD model and 50 design guidelines that you need to adhere to, the traditional way is you pull up your CAD model and you look at your 50 design guidelines and you go through each one line by line and say, am I compliant with this guideline or not? As we introduce knowledge models, we can start to take that manual evaluation out of the process, and the system can query the knowledge model. So we can look at what's in Auros and compare that automatically to what's in CAD. And then we're less reliant on a human's ability to go in and manually go through these 50 or 100 design guidelines. And we're able to do that in real time with some automation. So the characteristics of knowledge models are that they're precise, so we know exactly what's being evaluated, and the outcomes are clear. They're standardized, so the knowledge is captured in a clear and consistent format. And they're executable, ideally in a mature state without human interaction. So first, we're going to show you this video. It's assessment evaluation with attestation versus model-based evaluation. Here you can see a line item assessment. Given some context associated with the project, knowledge packets were delivered and are ready for evaluation. The first method of evaluation is attestation. In this scenario, the evaluator reads the knowledge packets, looks at any supporting documentation, and then manually selects a conformance state. So as the evaluator, I've reviewed this line item, and I've determined that I'm compliant with the requirement, so I'm going to manually select a read conformance state. I would then go through for each line item and manually select a conformance state similarly. As we start to better understand the knowledge, and as the knowledge matures, we can start to produce knowledge models. In this more mature method of evaluation, the evaluator is prompted to input a value, and that value is compared to a rule or requirement. That comparison then automatically produces the red or green. When you're in an assessment that contains knowledge models, you can open up the knowledge processing engine by clicking the lightning bolt, and you'll see here that you're prompted to input a value. So this line item is saying we have a maximum hole-to-edge distance of 24 millimeters. My hole-to-edge distance is 25 millimeters, so I'm going to enter that value here and click Evaluate and Close. The system then automatically evaluates the knowledge model, and you can see that I'm not compliant with this requirement, so the line item is red. Thank you. Are there any questions about the difference between the two methods of evaluation? Okay, the next demonstration is creating a value table. So this is going to be a very basic example about how you can add a value table to a knowledge packet. To author a value table, we need to first create a knowledge packet. To create a KPAC, we'll navigate to the KPAC menu, click Create New, and then select Basic. Our KPAC window will open. We'll then name our KPAC. We can give it a description. And then we'll open the value table editor where we'll author our rule. So the first thing you'll notice when you open the value table editor is there's a parameter name. The parameter is what you're trying to evaluate. So for this example, we're going to change the parameter name to be part thickness. Click continue. Next, I'm going to select the column type. The column type tells the knowledge processing engine how to behave. So for this example, we're going to select a minimum. So we're authoring a rule for a minimum part thickness. Let's say our value is 5 and our units are millimeters. Our rule states that we have a minimum part thickness of 5 millimeters. Now, before we save our KPAC, we can test our value table to make sure it's operating as we expect it. And here you can see you're being prompted to enter a part thickness, and you have a rule stating that it should be a minimum of 5 millimeters. If I enter a value of 4 millimeters and I click evaluate, we'll receive a fail output state because we have not met that minimum requirement. But if I instead change this value to 5 millimeters and click evaluate, we receive a pass output state because we are meeting that rule. So now that we can see our value table is working, we can click apply and close and then save our KPAC. So there are a lot of different types of value tables you can author. It's a very basic example of one of the options. And the next demo we'll show is authoring a decision model. So Ashley talked a little bit about methods. You can do process methods or decision model methods. This one's going to show you a decision model. To author a decision model, we need to create a method knowledge packet. To create a method knowledge packet, we navigate to the KPAC menu, click Create New, and then select Method. A knowledge packet will open. We can then give it a title and a description. And then we'll open up the method editor where we can author our decision model. In this example, we're going to have 2 possible conditions of assembly, which each lead to a different set of instructions. So under one condition of assembly, we're going to follow instruction A. And in the other condition, we'll follow instruction B. I'm going to rename our parameter condition of assembly because that's what we're evaluating. And then I'm going to select reference type because we're referencing the condition of assembly to determine an output branch. Under condition A, we will follow instruction A. And under condition B, we'll follow instruction B. I'll apply and close. I'm going to save the KPAC. And then we can find this KPAC and execute the decision model. So I'm opening up that KPAC we just created. And you can see we're being prompted to evaluate the condition of assembly. I'm going to select condition A. I'll evaluate and close. And you can see we're being prompted to follow instruction A. If I instead select condition B and evaluate and close, we'll be prompted to follow instruction B. So it's a very basic one-step decision model. These can get as complex as you want them. They're completely customizable. And if instead of a decision model, you want to use a method to model a process, there's also the flexibility to do that. Are there any questions about value tables, decision models?
I guess a question I would ask is, during the design process, these tables and stuff seem very black and white. And sometimes, how would you put an exception? Let's just say, yeah, my minimum's this, but I know with the way I'm applying, let's just say a snap feature, and I'm only going to do it once. I can yield a little bit, but I don't want to yield a lot. So I can go beyond a stress, a maximum stress that they say you're allowed to do. How do you put exceptions into that, or because if you're now going through the design review, and people who don't understand or don't look at it, they're going to go, "Oh, you can't do that." I've got to be able to have some data, something to be able to say, "Yeah, it's fine."
Yep, so-
Experience has to come in at some
Right.
point.
So the exceptions are typically handled through other assets. What we would typically see is we still authored the design rule with the requirement and then use something like issues management to raise a deviation request. And you can put an explanation there, work through it, get approval on that, and handle it that way. We can also put conformance states in the assessment that signal that we're deviating from the rule. So we would handle it through other assets, but typically we'd still author the rule as you have it written and then handle deviations outside of the value table.
Any other questions? Oh yeah, great.
So you gave an example where you showed one of the best practices with the thickness, and you were able to type in like the value was 4, and then it turned red when it didn't meet that. Is there a way to, like, let's say that value of thickness, and I have a thickness of a cup, and is there a way to kind of bake that value into a part in NX so that Auros can read if I'm adjusting the thickness of the part and I don't meet that conformance state? Like Auros can just read it automatically and let me know while I'm designing a part, like, hey, like the thickness isn't enough. Is that?
So are you asking if Auros can check NX to see if the requirement is being met, or if NX can change the requirement?
If I'm just wondering if like if I don't meet the requirement while I'm designing a part, can it read that value into Auros and let me know, hey, I'm not meeting that?
Yeah, so
If that makes sense.
we can connect to CAD systems, and we can do that connection automatically, where we're checking the model and saying, do we adhere to these design guidelines or not? So that you don't have to go in there and manually type in that number and click evaluate and close.
So like, how does that like that link work between NX and Auros?
It's APIs.
Oh, APIs.
Yep.
Okay.
Does that answer your question? Okay.
We have a lot more information on that.
Yeah, there's a
connection.
whole presentation on SmartCAD, which it's being recorded. It's upstairs right now. It's being recorded though, so you'll be able to find that on YouTube.
Yep.
I seen the smart cat. I wasn't sure what it meant.
Yep.
If that's okay.
Yeah, that'll give you a lot more information. So luckily it's being recorded and you'll get to see that one too.
Good questions for sure. Anybody else? I have one for you, Mikayla. I always have questions. So, and I think you hinted at this a little bit, but I just want you to say it out loud so everybody's clear. How do you know when to add a value table to an assessment, or when should you add a value table to an assessment?
So that's really dependent on the maturity of the knowledge. So if you understand the knowledge well enough to add in a value table, for example, to have this rule versus having someone kind of have to read and determine whether or not they're conforming, we would recommend doing it. So if you're able to author the rule, have enough information, and the knowledge base is mature enough, we would recommend it.
Great, thank you.